Hi guys, welcome back to my channel. Today I want to talk about ions in solutions. So on MCAT doesn't necessarily ask you, here's the compound, and what is the name of it? What is the Lewis structure? What is the formula, right? But it's just everywhere on the Chem Phys and Biochem section that you really need to memorize all these to your heart. Okay, let's dive into this. All right, so I'm gonna give you two big categories of anion. One ends with ATE, okay, nitrate, carbonate, sulfate, phosphate, all the ATE ending ones. And then the other big category is the ITE, it ones, okay? So there are also anions, meaning that all the 8 group and ite group, they have negative net charge, okay? All right, so let's dive into the 8 group first. So the first one is nitrate, okay? So nitrate is basically nitrogen and 3 oxygens, okay? And then it has a net negative charge, okay? And then if you draw the Lewis structure, you have this, okay? And then the negative charge is from this, and this. Why? Because this is positive 1, this is negative 1, this is negative 1. So you have a negative 1 net charge, okay? All right, so this is a nitrate. Okay, now as you imagined, nitrate is nitrogen plus oxygen. So carbonate must be what? Carbon plus oxygen, right? So it's CO3, but this time it's a 2 minus, okay? Why? Because carbon is bonded to, let me show you, is bonded to these 2 oxygens that are both contributing to the negative 2 charge, okay? And then the other oxygen is neutral, okay? And then it will be helpful for you if you also recognize this structure on the OChem section, okay? That's carbonate. All right, so what about sulfate? So of course, sulfur and then oxygen, but this time it's not 3 oxygen, but 4. And then it has a negative 2 charge, okay? And then as you see, sulfur being the central atom, okay, negative 2. And then these 2 oxygens are causing the net negative 2 charge, okay? All right, so let's move on to phosphate. Phosphate is phosphorus and then 4 oxygens, but it has negative 3 charge, okay? Because only 1 oxygen has double bond and all the others are singly bonded to my phosphorus. So I have 3 oxygens that's contributing to the negative 3 charge, okay? All right, so speaking of phosphate, I want to relate this to some really important biology concept that is the backbone of DNA, okay? DNA backbone. So I have a picture here that show you this phosphate that we talk about, and then you see that because this oxygen now is bonded to carbon, so it's not negative anymore, right? So we have 2 negative oxygens here, and this oxygen is being neutral the whole time. But then once the phosphodiester bond is formed, that we see only 1 oxygen is negative. The other 3 oxygen, 2 are bonded to carbon, the other one's being neutral the whole time, right? All right, so this is what reminds me of when I talk about phosphate, okay? Really, this is the DNA backbone. This phosphodiester bond is really important. And then if you want to know how this bond is formed from the organic chemistry perspective, who are the nucleophile, who are the electrophile, please refer to my video called DNA replication in my biology playlist, all right? Okay, so now we can move on to the last 8. So the last 8 is chlorate, okay? So it's Cl, chlorine, and then how many oxygens? 3 oxygens, and it has a negative 1 charge, okay? So I have a Cl as my central atom, and then I have 2 oxygens that are neutral, 1 oxygen that is contributing to the negative charge, okay? All right, and then I give you a bonus one that is hyperchlorate, right? So what is hyper? Oxygen is hyper. So hyperchlorate has 1 more oxygen than chlorate, okay? So it will be ClO4 minus, okay? All right, so that's the 8 group, okay? Now we can move down to ite, okay? So the ite group, we have 3 anions, okay? And then basically, the difference between ate and ite is they have the same central atom, right? Like nitrate and nitrite, they have the same central atom. But ite, the compounds that ends with ite, they really have one less oxygen, okay? So I'll put a little star, one less oxygen. Okay, so nitrate, how many oxygens do nitrate have? Nitrate have 3 oxygens. So, which means nitrite will have how many? 2 oxygens, right? So it's NO2 minus, right? And then the Lewis structure will be something like that, right? And then this oxygen is causing the negative charge, okay? And then, okay, the next one is sulfite, okay? So sulfite, let's see sulfate. Sulfate has 4, okay? So sulfite will have 3 oxygen. So it's SO3, 2 minus, okay? And then the Lewis structure will be sulfur, oxygen, 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 2 minus, okay? Then it's this and this, okay? All right, the last one is chlorite, okay? Let's see chlorate first. Chlorate has 3 oxygens. So chlorite will give me 2 oxygen, ClO2 minus, okay? So Cl double bond to O is always neutral. And then this oxygen is doing the negative, okay? Negative net charge. All right. And then the hypochlorite, who is hypo? Oxygen is hypo, okay? So hypochlorite has 1 less oxygen than chlorite. So which means what? It's ClO minus, okay? Just 1 oxygen. All right. So these are the anions, okay? I mean, really not too bad, right? I mean, the central atoms that you need to mention, nitrogen, carbon, sulfur, phosphorus, chlorine, that's it, okay? And then 8 has more oxygens, 9 has 1 less oxygen, okay? And then now let's move on to the 2 cations you need to know. Cations are the ones that with positive charge, right? So the most important one is hydronium, okay? Hydronium, okay? So hydronium, the formula is H3O plus, right? Basically, it's the positive proton, okay? Hydronium. And then the other one you want to know is ammonium. So ammonium is NH4 plus, okay? When you have 4 things bonded to the nitrogen, then it gives nitrogen a formal charge of positive 1, right? 5 minus 4, 4 bonds, then you get positive 1, okay? So this ammonium really reminds me of something else that I want to remind you. What about ammonia? What about I don't know if I spell everything right. Ammonia, okay. Ammonia is NH3, right? It's a neutral thing because now nitrogen is bonded to 3 things with a set of lone pair, right? So it's neutral, okay? So that's ammonia. And then what about primary amine, secondary amine, and tertiary amine? They're also nitrogen being the central atom, right? Okay, so the difference of a primary, secondary, tertiary is that the primary really is bonded to just 1 carbon, okay? So I denote it with R group, and then R NH2, okay? So 3 things bonded to nitrogen, neutral, right? And then the secondary is that nitrogen is bonded to 2 carbons, 2 R groups. So I say R prime, NH, okay? And then as you imagine, the tertiary is 3, all 3 R groups that nitrogen is bonded. It doesn't have any bonding with hydrogen, right? So it's R prime, nitrogen, okay? All right, I just want to remind you that ammonium, this cation reminds me of all these, okay? All right, so that's the anion and cations, okay? So now we're going to expand our A chart, okay? We're going to expand our A chart, not some crazy expansion, but only that I am going to add a proton to my anion, okay? And then once I add a proton, you see the negative sign is gone, right? Because now I'm using the electrons to bond with the proton, right? The hydrogen, so that I don't need to carry this negative charge anymore, okay? And then I'm also going to add hydrogen to CO3, then it will give me 1 less, right? Negative charge. And then this will be HSO4 minus HPO4 2 plus, right? And then these will be what? HClO3 neutral, right? HClO4, okay? All right, so these are now what? These are now, after I adding a proton, the proton can dissociate. Then dissociating the proton, donating a proton. These are what? Acids, right? That's what acids do, okay? So let's figure out the name of these acids. The first one is nitric acid, okay? And the reason why I want to mention it because it's a strong acid. And then it will benefit you if you can memorize all 6 common strong acids, okay? It will help you on MCAT. All right, what about the second one? The second one is not a strong acid, but it is a really important thing that you really want to recognize. It's bicarbonate. What is bicarbonate? Remember the biological buffer solution? Water and carbon dioxide form carbonic acid. And then carbonic acid, it's a weak acid. It's a buffer system, right? So the weak acid dissociates into proton and bicarbonate, okay? This is really, really important high yield topic, the biological buffer. So make sure you check out my video also in my biology playlist. That's called respiratory physiology, I believe, or respiratory system, where I dig deep into the bicarbonate buffer system, okay? All right, so this bicarbonate, like I said, it's from where? It's from carbonic acid, right? So if I add one more proton, I will have carbonic acid, okay? And then it will be helpful if you recognize them in this form so that you don't freeze during the organic chemistry when you see the organic chemistry passages, okay? All right, so these are not strong acid, but they're important components of the buffer system, the biological buffer system. So here we go. All right, so the next one, HSO4 minus. Okay, this is called bisulfate. Okay, just like bicarbonate, we add a bi before sulfate, so it's bisulfate, okay? And then the reason I want to mention bisulfate is that MCAT is tricky, that sometimes it doesn't call it bisulfate, it calls hydrogen sulfate. So just so you know, okay, multiple names for the same thing. Okay, and then let's add one more proton to the bisulfate. Then I'll have H2SO4. Okay, now the negative thing is gone. Okay, this is important. Why? This is one of the most famous strong acids on MCAT, right? Sulfuric acid. Okay, once again, it's strong. Okay, strong acid. And then also, not only is it a strong acid, it's also a what? It's also a polyprotic acid, right? You see that there are 2 reactions. Reaction 1, it completes here. Reaction 2, further dissociation that completes here. Okay, that's a titration curve, right? It's a polyprotic acid, right? Okay. All right, and then let's move on to this phosphate acids, okay? So if I add one more proton, I can have H2PO3, just 1 negative charge, right? I mean, I don't want to overwhelm you, so I'm not gonna tell you what are the names of these because I don't think you need it for MCAT. But the takeaway of writing them down here is I want to show you something. Like this sulfuric acid, we say that, oh, it's a polyprotic acid, you know that, right? But what about MCAT gives you this, and then you don't want to freeze. You're gonna recognize, oh my gosh, it's just not SO2 now. It's just PO4 now. It's not SO4 now, okay? It's not sulfuric acid. It's some whatever acid that's related to phosphate group. But it is also a polyprotic acid. That reaction 1, 2, 3, right? I have 3 protons for me to dissociate subsequently. So like 1, 2, 3. All right? Okay. So that's why I put those in my chart. Okay. So lastly, I added a proton to my chlorate and a hyperchlorate. Okay. And then the one that you want to know is this one. Okay. Because this is another strong acid and it has a weird name. It's called a perchloric acid. Okay. And it's strong. Okay. So I said 6 strong acids. We already went through 3, right? This nitric, this sulfuric sulfuric acid, and then this is perchloric acid. Okay, what are the other three? Since we already went over three, let's do the other strong acids. Okay, so the other three strong acids are HCl, HBr, and HI. Okay, I'm gonna write down their name in just a second. I'll just tell you first. HCl is hydrochloric acid, right? And HBr is hydrobromic acid, and HI is hydroiodic acid. So did you know this? They all start with hydro, HYDRO, and then the first one is hydrochloric acid, right? The second one is hydrobromic acid, and then the lastly is the hydroiodic acid. Okay, all right. So that's the other three strong acids. Okay, now let's talk about strong bases. Since we already went over strong acids, why not strong bases, right? And then there are 4 strong bases that I think you need to know. It can show up on MCAT. I mean, MCAT never asks you, hey, list all the strong bases, right? It's just that you see these, in the experimental procedures of the passages, right? They use a strong base to titrate this and that, right? So you want to recognize them so that less stress, okay? So LiOH, lithium hydroxide, NaOH, sodium hydroxide. You know that for sure, right? KOH, okay? And then CaOH2, okay? So the first one is lithium hydroxide. And then the second one is sodium hydroxide. And the last one, the third one is a potassium hydroxide. And lastly, it's calcium hydroxide. So they all ends with hydroxide. Okay? Hydroxide. I can't talk anymore. Anyways, these are the strong bases. Okay. Now, lastly, I want to talk about hydration. Okay? So, what is hydration? So you might know hydrogen. What is hydrogen bond? But what is hydration? So hydration is basically, we know that in pure water and water, they react, right? And then they would form H3O plus, basically proton, and then OH minus, right? So remember this cation, H3O plus, I said it's called a hydronium a cation, right? And then this, the opposite of this is the hydroxide. Remember all the bases? The hydroxide, okay? All right, so that's water's reaction with it itself, right? But there are also waters that don't react with itself, right? So in this case, hydration can happen, meaning that an intact water, for example, like HOH, that's a good water, right? And then we know that oxygen is partially negative, hydrogen is partially positive. And then when the water molecules, when they are not reacting with themselves, when they are attracted to, let's say, this Na+, right? They're surrounding these fully charged atoms. That's called hydration or solvation, okay? And then this partial positive hydrogen can be attracted to Cl-, okay? That's called hydration. It's different than hydrogen bond because hydrogen bond is really this partial negative oxygen is attracted to another partial positive hydrogen of the other water molecule. That's hydrogen bonding. It's partial something with partial attracted to partial something else, right? Whereas hydration is partial something attracted to something that has a full charge, okay? And then also, hydrogen bond is not limited to oxygen being attracted to this partial positive hydrogen. Also, FON, remember fluorine and nitrogen can also be attracted to the partial positive hydrogen. All right, I think that I'm making this video so long and that's all about it. I hope that's helpful.